Smart India Hackathon project competition. The name of our project is IOT Imperium. We have purposefully chosen this word Imperium because it conveys the sense of dominance and expertise in IOT. The title of our project is IoT-based manual monitoring system. Basically, manuals are the underground opening that provides utilities to the access to the underground canals such as sewage system, drainage system. Manuals are not monitored properly. We have often seen that these days. So to maintain the manuals properly, we have created a system that uses sensors and monitor the manual by sending signals to the workers' phone. Our project aims to integrate the modern IoT technologies. Our project aims to integrate the modern technologies to continuously monitor the manual by sending signals to the workers' phone if something is wrong. Now we further proceed to the technical part.
Hello everyone. For sewage workers, some of the people for going through the sewage, they lost the loss of the day due to dangerous gases. We propose that solution on that. That for that controller, we can use the central microcontroller as ESP because ESP can give the signal for the multiple multi-range as a Wi-Fi model. Then sensor array deployment. We use the multiple sensor for the detecting the gases. For the gases, they are array deployment. We can use a multiplexer. Then real time and data transmission. We can create a web page. The web page can same as like our software login page. If it is detecting the various gases, then it will display on the monitor and the other channel notification system. We can use a GPS module because if somehow the dangerous gases can be increase their level up to particular level, it can give the notification from text message, then data storage analysis. The stored data can be analyzed. Due to that, we can verify that for multiple manuals, we can analyze in which manhole the blockage is there and dangerous gases can be increased. Power management. The power management is in that we can use the lithium-ion battery. Due to that lithium-ion battery, we can multiple times we can use the waterproof enclosure. We can use the multiple sensor for detecting methane gas and carbon sulfate and monoxide. Due to that, waterproof sensor can be used in various conditions, scalability and integration. The system is scalable for the environment sustainable and if user interface and dashboard. We can make the same as user interface, then safety and compliance. Due to that system, the safety of your workers can be improved.
So this is the basic block diagram. It's the flow diagram of the project. It's a bit complicated because there are very big number of blocks. So it starts with the power supply. The power supply is given to the battery, and the battery has a unregulated voltage. So it is regulated by a voltage regulator, and it is given to the microcontroller. Here the microcontroller uses an ESP8266. There are various sensors, that is water level sensor. Then there is a blockage detection sensor, and there is a temperature sensor, and then there is a gas sensor. Here the gas sensor used are three gas sensors, that is carbon monoxide, then there is a hydrogen sulfide, there is a methane, and the temperature humidity sensor we have used the AM2305B temperature sensor, which is just like a DHT11 sensor, which measures the temperature and humidity of the surrounding medium. And then there is a water level sensor. Here we have used the distance sensor, which is a waterproof sensor, which can measure the water level of the manhole. Because if the person wants to enter in it, we should check either the water is up to the brim or it's in a normal condition, either he can enter or not. So there is a water level sensor, and this all is interfaced with the ESP8266 module, which has a storage of 4 MB. So all this data can be stored in the storage ROM, that is EEPROM, where the HTML and CSS files are uploaded to show the user interface. And then there is the USB and UART ports to communicate with our sensor. And then there is the expansion port. Expansion ports here means to an I2C connectors, where we have to integrate multiple sensors with our ESP, but we are incapable of. So we can use the expansion port, that is I2C port, and then there is a waterproof enclosure. Here the waterproof enclosure means that we have to combine all the sensor and enclose them in waterproof encasing, because it's under the manhole. Sometimes there would be a water level increase, and then all the sensor would be in the water. So we have to make all our enclosure in a waterproof enclosure. So it's completely waterproof. And then there is a communication module of an ESP. The main reason we have chosen ESP8266 is that it has an ESP communication module which has an inbuilt antenna which provides a Wi-Fi. So we can just connect with the Wi-Fi and get all the data. So that's it. And here we can see that how it looks like. We can practically see it on the mobile. Let's see.
As we have discussed, sewage workers face different risks while entering in the manhole, while checking the manhole, and there are different toxic gases like carbon monoxide, methane in the manhole, which can cause harm for the health. And when workers enter into the manhole, so they can feel suffocated. So feasibility and viability of our system is component availability. So components which we have used in this system are easily available and they are affordable. Cost effective, that would be the components are cost effective, easily available and affordable, easy installation with minimal disruptions and user friendly, environmentally sustainable. So components used are environmental friendly, they do not cause any harm to the environment, enhances safety by preventing hazardous situations. So they prevent the accident as sensors detects the hazardous condition and they send alerts to the workers phone. Regulatory compliance with safety environmental.
Questions should be there from student side.
You connect to the Wi-Fi.
Uploaded.
So this is a Wi-Fi. Here it will show the complete monitoring of the data. Means what's the temperature level, what should you what is the application? So application area is that we can implement it in the sewage manholes. Means if there are manholes and due to which if the person is entering in it, he don't know what gases are there and what level is it. So he can suffocate and die. So rather than before going in it, he would just see in his mobile, or a worker has, now in this time everyone has the mobile. He can just connect it to the internet and check all the data. And there is a button in that. If you click on it, it will say that either it is safe to enter or not. If it is not safe, he can directly tell it to the municipal corporation to either clean it with the advanced equipments, or it will automatically go to the GSM model. If the limit is greater than that, it will automatically send a message to it. So.
So before that novelty, so very good sector we have selected because manholes are everywhere in the world. But I feel it is overuse of technology because a simple sensor can give idea whether there are gases or not. Simple indicator like red indicator, orange indicator can also show that if there are gases present. There is no need in my case, of IOT. Simply a person can insert a sensor and see if there are gases. What is the use of IOT?
So for a single manhole, we can see the indicator. Means if we are practically there, means we can see that there is a sensor. It is blinking red. We have to clean. But in a city, there are hundreds of manholes. There are thousands of manholes. But if we want to integrate all the things and get a detailed sheet of on an online forum, then we can just connect over it. Means we have GSM module. The GSM module sets the
same thing you have to show in PPT. That this can be integrated on urban level. The urban officer can see this you have to show in PPT. Thank you. Madam.